Hi, I'm Edipo. This tutorial is about the OSI model, which stands for the Open Systems Interconnect model. The most common referenced protocol model, the OSI model, was developed by the International Organization for Standardization, ISO, to provide common ground when describing any network protocol. The ISO is not an acronym for the International Organization for Standardization. It was adopted from the Greek word isos, which means equal. Now the OSI model. Using the mnemonics, all people seem to need data processing. We'll have the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical layer. Going from the bottom to the top, we could use the mnemonics. Please do not throw sausage pizza away. That's a physical data layer, network layer, transport layer, session layer, presentation layer, and application layer. The OSI model consists of 7 layers. Each layer performs a specific function and passes the results onto the next layer. The application layer defines how interaction occurs between network services, that's the applications, and the network. Services that function at the application layer include but are limited to file, print, and messaging services. The application layer may also support error recovery. The top layer of the OSI model does not refer to applications such as word processors. The presentation layer. This layer formats data exchange. In this layer, character sets are converted and the data may also be compressed in this layer. This layer usually handles the redirection of the data streams. The session layer. This layer defines how two computers establish, synchronize, maintain, and end a session. Practical functions such as security authentication, connection ID establishment, data transfer, acknowledgement, and connection release take place here. This list is not all-inclusive. Any communication that requires milestones, or put it in your own way, have you got the data ascent? Answers are performed here. Typically, these are called checkpoints. Once a checkpoint has been crossed, any data not received only needs transmission from the last good checkpoint. Adjusting checkpoints to account for very reliable or unreliable connections may greatly improve the actual throughput of data transmission. The transport layer. This layer checks the data was recovered error-free. It's also used to provide a message that is too long into smaller segments, and in the reverse, take a series of short messages and combine them into longer segments. These broken up and combined segments must later be corrected by reassembling. This is accomplished through the segment sequencing, usually by appending a number to each of the segments. This layer also handles logical address, which can also be called name resolution. Additionally, this layer can send an acknowledgement that I received a data packet. Frequently, you will see this referred to as ACK, which is a short form for acknowledgement. This layer is responsible for the majority of error and the flow control in the network communications. The network layer logically addresses and translates logical names into physical addresses. A little known function of the network layer is prioritizing data. Not all data is of equal importance. Nobody is hurt if an email is delayed a fraction of a second. Delaying audio or video data a fraction of a second could be disastrous to the email. This prioritization is known as quality of service, QoS. In addition, the network layer controls congestion, routes data from source to destination, and builds and tears down packets. Most routing protocols functions at this layer. The data link layer. This layer takes raw data from the physical layer and gives it a logical structure. This logic includes information about where the data is meant to go, which computer sent the data, and the overall validity of the byte sent. In most situations, after a data frame is sent, the data link layer then waits for a positive acknowledgement denoted as ACK. If one is not received, or if the frame is damaged, another frame is then sent. The data link layer also controls functions of logical network topologies and physical addressing, as well as data transmission, synchronization, and connections. The physical layer. This layer controls the functional interface. For example, transmission techniques, the pin layout, and the connection type. Thanks for watching.